kind of more lecture-y portion. I'll record that and then I will post that to D2L. So if you do happen to miss one of these class periods, you can access what we talked about in class, or at least this portion of it. Or if you're following along in class and then afterwards you're like, oh, I can't really remember what he did there, you can go back and look at this. And so that'll be posted in that content section, right? I just uploaded them just like YouTube videos, so you can access those whenever you want. So circles here are a type of graph. And remember, a circle is the set of points that is sort of equidistant from a radius, right? Like if you put a pin there, or sorry, from the center. If you put a pin there in the center and then, stretched a line out and drew it around, that would create a circle. And so you may remember that the distance between 2 points, there's a formula for that. So we're going to call the circle here, its center is going to be HK, just arbitrary letters that represent the X and the Y coordinate of the center. And then we want to get all the points XY. So XY are all these points that create the circle. And they're all the points that are a distance R from the center. So the distance formula looks like this. You take x1 minus x2 and you square it, and you take y1 minus y2 and you square that. So that gives me the distance between any 2 points, x1, y1 and x2, y2. So in our case, we want to find the distance between the center and this xy, and that distance should be equal to the radius. So r equals the square root of h minus, let me write it this way. What's the best? Yeah, let's start with this. Rather than h, let's start with x minus h. It doesn't matter which order when you're squaring it. That's one of the nice things about this formula. Okay, so x minus h squared and y minus k squared. And that distance formula is just the Pythagorean theorem, actually, right? The change in y values is this distance. The change in x values is this distance. If you square them together, you get r squared. And so if you take the square root, you get this formula. So what we normally do, this equation here is the equation. If I have a radius and a center, this is the equation of a circle. Any xy that makes this equation true is going to have a distance of r from the center. Therefore, it's going to be somewhere around this circle. We normally like to square both sides of this and rewrite it in this kind of nicer form. And so we want to think of that as our equation of a circle. In the same way that you have an equation of a line, right? This is the form or the general form of a line. You can read some information about the line, right? I can read the slope and the y-intercept just from looking at that equation when it's written in this kind of nice form. We call that standard form typically, or slope-intercept form. It's the same idea with the circle. When a circle is written in this form, I'm able to read off what the center is and what the radius is. So for example, if you have x minus 2 squared plus y plus 3 squared equals, say 10. I recognize that this is this general form, the equation of a circle. And so I can tell you just from looking at this that the solutions to this fall in a circle, And the center of that circle, it's going to be the opposite values, right? So if it's x minus h, the center is at h. So for x minus 2, the center is at 2. For y plus 3, then the way that it's the opposite of that, because it's minus. Okay, so this is going to be a center of minus 3 for the y coordinate. And then this value here is r squared. So r must then equal the square root of 10. So just like a little bit more than 3. And so from that, right, I know my center is 2. Negative 3, something like that, and it has a radius just slightly more than 3. And it's an okay circle. Okay, so once you've kind of mastered this equation, you can use the equation to find out information, or I can take information and use it to come up with the equation, right? I can go back and forth either way. But when we're working with circles, we really want them to be in this form. You can square this out and square this out, and it's still a circle, but it's going to be harder to see what the center and the radius are. Okay, some questions here. Yeah, sorry about the book. I missed those. We'll get back to that in a second. Any questions about circles? Okay. So again, that's kind of what we'll do. I'll just go over and